All right, so we're going to work on the next two examples. So let's start with 2 sine squared theta minus 3 sine theta plus 1 equals 0. So I want to have an expression with just a trig function equal to 0. Any ideas like what kind of form this looks like here? Like thoughts about how I could deal with this?
It looks like quadratic.
Doesn't it? It very much looks like a quadratic, so maybe we can factor it. So let's try 2 sine squared theta. I can only get that by multiplying 2 sine theta by sine theta. And I can only multiply by getting 1 if they're both 1, either both positive or both negative. And in order to get a negative 3 when I add, they have to both be negative. Now let's check if that works. I know that my constant term works and my sine squared term works. My middle terms are negative 2 sine theta minus 1 sine theta. That does in fact give us negative 3 sine theta. All right, so we got it. So now we just need to solve. So 2 sine theta minus 1 equals 0. Is it okay if I do 2 steps at once and say this equals positive 1/2? It's not okay. I added 1. And then I divide it by 2.
Yeah.
Okay. And I will save this other expression for later, but I'll at least write it down. So that's going to give me a different set of solutions because I'm still doing all solutions. So where is sine of theta equal to positive 1/2? That happens at pi over 6. And it also happens at 5 pi over 6. Do you agree? Okay. And then I'm looking for all solutions. So this is sine. So every 2 pi, I get another one. So plus 2k pi. And then again, k is sure. So that's one set. But I get more. So if I solve this for sine theta equals 1. So where does sine equal 1?
Pi over 2.
Perfect. And nowhere else, right? Nowhere else? Okay. So plus 2k pi. So 3 sets of solutions. All right, now this one. I have sines and cosines in here. So factoring it like a quadratic is not going to work. But there is a common factor, and the common factor is cosine. So if I factor cosine of theta out, I'm left with 5 sine theta plus 4. So if I set each of those factors equal to 0, so where does theta 0? So what I was actually trying to say is what angles have cosine equal to 0? Pi over 2, one of them. And then if you keep going and you land on the y-axis again, 3 pi over 2 is the other one. And then we're still looking for all solutions, so plus 2k pi plus 2k pi. K is an integer. And now this one I have to solve. So sine of theta equals negative 4 over 5. So I subtract 4, divide by 5, and then I type this into the calculator because that's not a special value. So sine inverse of 4/5. And that gives me, negative 4/5. Negative 0.93. So one more of my sets of solutions is negative 0.93 plus 2k pi. Now, usually we pick our first angle to be in quadrant 1 or 2. It's okay that you leave it there, but if you really wanted to add 2 pi, it would put you back in quadrant 1. But we still get all of them by letting k be all integers. So this gives us the same set. But we also have to find the other solution because this is actually not inputs around the circle, but negative. But I still have to find other answer that's in another quadrant in the circle. So let me do a quick visual here. So I have to think about where negative 0.93 is. So I'm going this direction, and if I go halfway around, that would be negative approximately 3. So this is less than 1, so it's going to be over here in quadrant 4. So this is angle negative 0.93 approximately. And I'm talking about sine of an angle. So the other place that sine is negative is over here in quadrant 3. So if I want to find out what that angle is, get me my other solution, I can take pi, that gives me halfway, plus the reference angle, which would be the same size as this one, but of course it's adding a positive. So I'm going to take pi and add positive 0.93 or subtract negative 0.93. And that gives me my other solution. And that works out to be 4.1 approximately. So that was one set, and another set would be 4.1 plus 2k pi, because of course we can keep going around the circle to get a set of solutions. So I have 4 different sets that are all solutions to that equation.